Alright, this is Honors Purple Book, Chapter 1, Lesson 8. I'll be doing the guided practice off page 74, talking about square roots and cube roots. To review, this is called the radical sign that shows us that we want a root of 1.69. Remember what that is we're breaking this into what times itself. In other words, what squared got me to that number. The way to undo a squared is to do a square root. So if I take 1.69 and find the square root of it, something times itself got me to 1.69. That would be 1.3. Notice they have the negative. They want the negative square root, because remember, negative 1.3 times negative 1.3 is 1.69. Also, 1.3 times 1.3 is 1.69. They wanted the negative square root this time. Okay. Remember, if you have a square root of a fraction, you're really saying I want the square root of the top one and the square root of the bottom one. So the square root of 49, what times itself gets you 49? 7. Right? And what times itself gets you 144? 12. And so the square root of 49 is 7, the square root of 144 is 12, so the square root of 49 over 144 is 7 over 12. They want the positive and the negative, so we will put positive, negative. Positive 7 twelfths or negative 7 twelfths. Both of those are square roots of 49 1/44. Number 3, the square root of negative 1.44. Now we have an issue, because is there something that you can take times itself and get a negative? The problem is a positive times a positive is still a positive, and a negative times a negative is also a positive. You see a problem? There's no way to do this. So, to be honest, our answer right now is no real solution. Eventually you get into imaginary numbers, but there's no real solution to this one, because we can't have a square root of a negative number. Alright, number 4. P squared equals 36. Now they want us to find out what P is. Well, once again, we talked about how a square root undoes a square. So if I look at this and I'm solving it like an algebraic equation, somebody took some number times itself and they got 36. If I want to find out what that number was, I undo what they did. I do it to both sides. Square root of P squared, of course, is P. Square root of 36, what times itself got me 36? Well, it was either negative 6, because negative 6 times negative 6 is 36, or it was positive 6. Positive 6 times positive 6 equals 36. Alright, same thing here. Undo it by square rooting it. Square root of 1. Remember, you can think about this as a square root sign and square root. So we have square root of 1 is 1. Square root of 9 is 3. Once again, could be positive or could be negative. So there's your positive, there's your negative. We have two possible options there. Number 6. When I look at number 6, I'm going to say, okay, well, once again, I need to square root it to undo that squared sign. So I'm looking for 6.25 with the square root of it, which is, you'd probably want to grab a calculator if you don't just remember that number. See, these are perfect squares. 625 is 25 squared, so I know that this would then be 2.5 equals R. Once again, it could be positive or it could be negative. Number 7. Now we're looking at not a square root, but this little 3 notes a cube root. I want to know what times itself again got me to 216. Alright? Once again, we're dealing with perfect squares and perfect cubes. Those are the ones that are done with whole numbers. Or integers, I guess I should say, since we sometimes deal with negatives. By the way, you could find a cube root of a negative number, because a negative times a negative times a negative does give you a negative. Does that make sense? Alright. Couldn't find a square root, because nothing times itself gets you a negative, but something times itself again could get you a negative. So when I'm looking at this, the cube root of 216, well, 6 times 6 is 36, and 36 times 6 is 216, so that would be positive or negative 6 would be the cube root. Same thing here. Now I know it has to be a negative, because it would have to be a negative times itself again. That'd be 3 negatives. You always see me count those on my fingers, right? An odd number of negatives make a negative, so when you're multiplying and dividing. So I recognize 125 as 5 times 5 times 5. Since it's a negative in there, it must have been negative 5 times negative 5 times negative 5. So negative 5 is the cube root of negative 125. Next one, once again, you have a negative number in here, so I know my answer is going to be negative cube root. We're dealing with perfect cubes, so 2 times 2 times 2 is 8, so negative 2 times negative 2 times negative 2 is negative 8, so negative 2 would be your cube root. Number 10 is talking about a cube-shaped packing box. It can hold 729 cubic inches, that's a volume, of packing material. Solve 729 equals s cubed. 729 equals s cubed. They even gave you the formula or an algebraic equation. So once again, how do I undo a cube? I don't take the square root, I took the cube root. Because I know they took this length times this width times this height to get the volume of this. And since I know it's a cube, those are all the exact same measurements. So something times itself again got you to 729. Once again, you can use your calculator for some of these if you don't know these answers, but a lot of these are perfect cubes that you'll get used to seeing a lot. So 729, of course, is 9 times 9 times 9. Now this is one that I would put only a positive 9 inches. Why? Because does it make any sense? Although, oh well, we're on a cube root anyway, so I guess it doesn't make sense to have a negative either. But could you have negative 9 inches on a box? No, that doesn't make sense. Okay, so last one I want to do is just estimating a square root. I want to show you the process to estimate in case it doesn't come out even. This is not a perfect square. Well, first of all, you need to know the perfect squares. That will get you started. So I'm going to find out what perfect square it's between. Well, 6 squared is 36, and 7 squared is 49. 40 is somewhere between 36 and 49. I will do a subtraction problem to find out how many numbers there are between 49 and 36. There are 13 when I subtract those. And then I want to find out kind of how far along the continuum from 36 to 49 40 is. So I would do 40 minus 36. 40 minus 36 means I'm only 4 steps of the way there, so I would be 4/13ths of the way to 49. Notice I got this from the distance between the perfect squares that it's between. I got this by subtracting the number I actually want from the lower one to find out how far along on this continuum I am. There are 13 steps to get there. I'm only 4/13ths of the way. So a decent estimate for this would be 6 and 4/13ths. Now 4/13ths is not exact. Let me do that on my calculator real quick. 4 divided by 13 is 0.307. So let me show you what this would be. 6.30769. I'll just stop there. Okay, that's what I get with my estimate. That's 6 and 4/13ths. Now if I actually do 40 square root on my calculator, I get 6.32455 ... So once again, this is a good estimate. We generally get you to the nearest tenth. So that will be about as close as we're going to get. We're not going to get an exact answer, but 6.3 would be a pretty accurate estimate for that. Okay.